let's look at some non-permanent ways to join our prints together. The most popular methods use screws or bolts, but to do so we're going to need to strengthen our mounting holes, so we're going to have to go back and learn one more important advanced slicing skill. Let's say this is our part, and these are the holes that we're going to be bolting through. Now we're going to want to make the shell thickness around these holes a bit thicker and give us a bit more strength. Now you could set the shell thickness larger on the whole print, but we want it just localized entirely within this area. To access this tool, you're going to need to select the advanced mode in the top right here, then right clicking on the part, we'll now be able to see the add modifier option, and we'll select cylinder under that. Now we're going to drag and scale our cylinder so it intersects the hole that we want to reinforce. And we just want to make it a few millimeters bigger than it like so, also making sure that it intersects through the top and bottom of the hole as well. Now this modifier shape will let us change the slicing settings just where it intersects our part. So we're going to select layers and perimeters, and then we're just going to bump up those perimeters a fair bit. And as we can see, this intersecting area has been filled with a bunch of extra walls. Alright, first way to fasten your prints. You get a bolt or a screw, you model your print to be 0.1 millimeters smaller than the diameter of the bolt, and then you screw it in for dear life. It's the easiest and laziest, but not the best way to secure your prints together, because it's only going to take a few cycles of tightening and untightening to strip or wear down the plastic thread that you've made. It's not the most optimal method, but I do use it sometimes on things that will shortly be thrown in the bin, or something that's just a prototype that I know will be replaced soon. A better way than using the plastic as a thread is to embed nuts and bolts into your print. As we saw earlier, this part is designed so that a nut can be placed in this cutout here, and a bolt can come through here and thread into it and attach it to a mounting plate. Here's another example where you can just embed the nut and use it as a thread as you tighten the bolt from the other side. And this is a huge advantage to 3D printing. You can just very easily embed a bolt or a nut anywhere and hold your parts together. And there's so many ways to do so. It's just a matter of getting creative. Now, let me introduce you to threaded inserts, the creme de la creme of fastening your parts together. So you have this threaded brass insert, you get it real hot and then you sink it into your print. It sits nice and flush, it looks professional and it's going to be one of the strongest ways to fasten your print, as that brass insert is really well secured. It's also pretty cheap, and for how strong and professional it is, it's really easy to do. So in CAD, where we want to place our thread, we'll need to make a hole slightly smaller than the outer diameter of our insert. 0.6 millimeter is a good rule of thumb here. Now if we're making a through hole like this, we're done in the CAD phase. But if we're making a blind hole where it doesn't come out the other side, we'll need to make that hole as deep as the threaded insert, plus a millimeter or two. And this is because when you sink it, the plastic will melt and be displaced. The extra depth in our hole ensures that that plastic has somewhere to go and that it won't backflow into your threads. For most threads, you'll be able to find a document that'll give you exact dimensions of that hole that you need to model, but 0.6 millimeters smaller in diameter and 1 to 2 millimeters deeper for a blind hole, it's a good ballpark if you can't find anything. Now for a heat source, we'll just be using a soldering iron. It's handy to use the tip specifically designed for sinking threads, but you can get away with a regular tip. We have an explanation why in the wiki, but long story short, the method that we're going to show you how to use here will let you get away with using a regular tip. We're going to set our soldering iron temperature to about 10 to 20 degrees above what you print the plastic at. So for PETG, this is about 240 to 250 degrees. Once up on temp, we're going to rest our insert on the hole, grab the soldering iron, and then just push the thread in. You don't need too much force, and just the weight of the iron and your hand will be enough. Let gravity do the work. Just make sure you're sinking them in nice and square. You don't want any misaligned inserts, or you're going to have some trouble putting your parts together later. The sinking process should take about 10 to 15 seconds, and you just want it to sit nice and flush with the surface of your part. Let it cool, and now you can whack a bolt into your nice and tightly secured insert.